I hope you can hear me clearly. If not, you can inform. So today I will just go through some content related to logical design of IoT. So I believe some I will like not spend a lot of time on this section. So this actually is a theoretical concept, logical design of IoT. So it actually means that you can uh, do a logical design based on the IoT network requirements and the kind of the constraints that are there in the IoT network. So, I mean, let's say, for example, if we take an example like this, where we consider a situation where we have the smart agriculture. So if a customer comes to us and asks us to design an IoT network based on this application, the engineer first has to understand what are the specific requirements of the customer. Also, they need to understand how the IoT network, specifically for this application, will have some constraints, right? So there could be some constraints in the environment. So in terms of the energy level in the devices, in terms of bandwidth for communication, in terms of storing energy at the embedded devices, the efficiency of data transmission, and then where to store the data. So whether there are some, sufficient data storages. So those things will have to be considered when you are doing a IoT system. IoT system design. So before even going for the hardware implementation, the IoT system designers have to first think about this logical design of IoT. So I think in the past weeks we have discussed about how we do this using the hardware protocols. I mean hardware and the different IoT protocols that are available. So we discussed about different methods of implementing it. However, we need to add this logical design part also, because in order to do the initial evaluation about the feasibility of the project, right? So we have to do some feasibility analysis and we have to check whether we can implement our IoT network or not. Um, and also we need to check whether we can actually give the expected output to the customer. So basically, logical design of IoT means that you are planning a network in a global sense. You understand like what is the expected outputs from the design, and what are the limitations that are there in the network, and how we can manage the available resources and achieve the expected outputs. So there's no need to remember what I have shown in this slide. So you just need to know that logical design means that you are planning ahead about the IoT network by considering the different challenges that are there in the IoT network, and also by considering the requirements that the customer has requested us. So logical design means you are logically thinking how this IoT system is going to work. Based on that, you are going to decide the hardware that you require for your system, the protocols that you require for your system, and so on. The logical thinking is what is necessary for this logical design, right? So whenever you are given some task to design an IoT network, you have to think what are the suitable hardware, what are the suitable protocols, what are the suitable infrastructure required for the implementation. So that is known as logical design. So apart from that, like logical design can be like categorized into three main uh, like sections. So when we are doing a logical design, we have to consider about these aspects as well. So the first section is functional blocks of IoT. The functional blocks of IoT, what are the functions that are generally defined for our IoT system? Then IoT communication models. What are the communication models that are defined in general for a IoT system implementation? So um, the general communication methods that can be used uh, for a IoT network is considered here. So thirdly, IoT communication APIs, application programming interfaces that can be used for the IoT network. So we will discuss one by one. I will give an idea very briefly. So functional blocks of IoT uh, basically is the functions uh, that are necessary for an IoT implementation. So functions means that like what are the different aspects that um, are required for IoT network. So when we talk about these functions, we can divide it into different categories. So at the device level, we have to do different functions. At the device level, we have to do sensing, we have to do monitoring of the data, right? Monitoring of the, monitoring of the environment and collecting of data based on maybe some um, monitoring algorithm. So basically at the device level, you have the sensors, and you will be doing the sensing using the sensors. So you will be collecting some data. Using the collected data, you can do some monitoring regarding the environment. So that monitoring you can do at the device level itself. Apart from that, you can also control the device, its functions in terms of mechanical functions. You can control them at the device level itself if the device has the capability of making decisions. So it can control the actuation and any other control functions. So actuation means the process of controlling motors, the process of controlling wheels, that kind of dynamic systems that are there at the device level. So in here, what I mean by device is a, a device which can be either embedded system, like a very small or a small scale device, or it can also mean a large scale device. So, it can be even a robot. So in that case, we can consider these actuation and control functions also as important functions that need to be done at the IoT network level. When we talk about the other functions that are done in the IoT system, we'll be basically doing management functions, where the management is used for basically the data collection, data storage, and then data management. You need to manage large amounts of data. If there is a load of data that is generated from the IoT network uh, per certain time instance, then you need an efficient method of managing the data rather than having no management system. So once you have large amounts of data, they have to be categorized in an appropriate manner, and then they have to be controlled in a sufficient in a good way, such that the data doesn't get lost, one thing, and then that the data can be used for other purposes, such as informing the customer about the nature of the IoT network, and about informing the user about the near future, what is going to happen in the near future. Using machine learning, AI, those techniques, now we can do some predictions about the environment. So those things can be enabled once you manage the data properly, and once you send the data to the necessary authorities on time, and make those authorities process the data and inform the customers some useful data. Then you have also some services that IoT system provides to the customers at the IoT system level. So for example, let's say you are building a smart vending machine. So smart vending machine can be a service that you provide to the customers. Then communication. Communication is another aspect that is a must. That is must for IoT network, right? Without communication, it's not going to be IoT. So you need to have the connectivity between each and every device in the IoT network such that every device can talk to another device. So that is the main goal of IoT. So increasing the connectivity between devices. The communication aspect is really therefore essential. So based on your requirements, you need to select the communication technology that you need and then select the suitable one based on your application. Security is also another function or another feature that is very vital in the IoT networks. So in the last online class, I think we had this discussion regarding IoT security and the security in IoT networks. As of now, there's still a huge challenge related to the IoT system security, right? The security, maintaining security is still a huge challenge for the IoT system designers. If somebody is designing an IoT network, it's challenging for them to secure the network against unauthorized access. The main reason being adding security to the IoT network protocols increases somewhat the complexity of the communication. However, there's no option to leave out security out of the data transmission. So in this era when we are all transmitting data to a certain endpoint, we want to make sure that our data is encrypted and that our data is decrypted only by the designated receiver, right? Otherwise, we don't want our data to be exposed to another intermediate person. So in order to achieve that, now many research works and industrial works are going on to propose some methods to overcome the security attacks and then ensure the security of the communication. After that, we also need application layer or an application for our IoT network. So normally we have to design a good application for our IoT network, and that application should clearly give the message to the customers regarding some certain aspect of the IoT network, and then it should be able to clearly obtain data from the customers as well. So the application is another important factor that should be enabled in an IoT network. So without an application, we cannot access the data from a remote location. So if you have an application that can give you some useful data, it would be an added value to the users. So when we talk about the second category, so we were discussing about the different categories, so different sections under which we can discuss about the logical design of IoT. So we have these three sections. Currently, we have discussed about the functional blocks of IoT. Next, we will be talking about communication models. What are the main or very common communication models used for IoT? So that is what we are going to discuss. Right, so the most common communication models that can be used in IoT systems or networks is request response, publish subscribe, push pull, exclusive pair, etc. So these are the four main, these four ones: request response, publish subscribe, push pull, exclusive pair, are four types that are very much used very popular in a popular manner. So these communication models are not a new thing to you, I think, because we have discussed about the request response model, The request response model is used in the HTTP communication scheme and COAP communication scheme. So therefore, it is not a new communication model that you are not familiar with. So then we have publish subscribe model. So publish subscribe model was used in the MQTT protocol. So that is the protocol for publish subscribe MQTT protocol. After that, push pull protocols are there, and exclusive pair protocol is there. So when we talk about the request response model, it basically sends a request to the server and receives back a response from the server. So the server, in the meantime, after it receives some request, it sends that request to the resource directory, right? So the place where the resources are stored, I will call as resource directory. So to that point, the request is sent, and I mean to the server, the request is sent, and the server will communicate with the resources and will obtain the necessary resources that the client will be requesting. So after obtaining that necessary data, the server will send a response message back to the client with the requested data. So the requested data will be shared by the server with the client after it receives that information from the resources, right? So the server is able to obtain any resource files from another location in the in the command. So the server can obtain any resources by connecting to the resource location in the network. So the server will have connection to the resources and obtain the necessary resource that the client has requested. So request response communication model is basically used by protocols such as HTTP protocol, right? So that is HTTP protocol, COAP protocol. Those protocols are the common protocols that use request response model. When we talk about the publish subscriber model, publish subscriber enables us to send a data to a certain receiver through certain topics that we define. So there's a MQTT broker, publisher, and subscriber. So the broker has has several topics that are defined in the system, and then the broker, once it receives some messages from the publisher, the broker will publish those data at the subscriber. So that is basically regarding publish and subscribe model, and we have discussed about the MQTT protocol, which is very similar to this one. Next, we now come to a new model that we did not speak about in the last class specifically, but this is a protocol. This is a communication model, one of the communication models that use a push-pull method. So this protocol can be used under MQTT, under AMQP, XMPP, such kind of protocols. And the main thing that happens in here is that the data will be stored in queues in the broker, right? The data will be stored in queues in the broker, and the publisher will keep sending the data. So due to the data not being transferred quickly to the customer, there has been a queue generated in the broker. So this is an example figure of AMQP protocol, right? AMQP protocol. So AMQP protocol is a protocol that uses push-pull algorithm to transmit its messages, right? So normally push-pull message method is used for scenarios where you have huge loads of data, right? And that you cannot really send one data and just like assume that communication has been done properly, but rather than that, you need a really good like you need to have a really good communication link between the transmitter and receiver, uh, and so that will enable them to do the communication. So basically AMQP, or we call this as advanced message queuing protocol. Advanced message queuing protocol. Advanced message queuing protocol. And this is known as AMQP for short. So this is one of the examples for this, push pull message model. And in here, actually, if you take the clients, there are two clients. The clients are sending messages. The clients will be sending messages to the broker. The broker will have different, advanced methods uh, to obtain data and categorize the data in the broker itself. So at uh, the broker will give the responsibility of collecting data and then placing the data in the correct queue to something called exchange. So exchangers, this component in green is known as exchanger. So if the exchanger is given some data, that data has to be put to one of these queues. So that performance will be done by this exchanger. After you receive the data, and then once the data cannot be transmitted very frequently to the client, the data will be stored inside the Pradeepa Miss. Sorry, the data will be uh, stored inside the queues, and once the queue is uh, sent, once the queue is um, created, and then once the client is requesting the message, the queue will be emptied. So uh, the the rate at which the data is pushed, the data is pushed in here to the broker, and the data is pulled out into the clients through this place. So basically push and pull mechanisms are like that. The push of the data will be happening at a certain rate, and that rate will be a certain rate which can be different to the rate of pulling out data at the client side. So there could be some rate of lambda 1 at the push location, and there's a rate of pulling out data at the receiving location. So the rates will be changed uh, under the functions push and pull. So these rates will be changed, will be different. So that is basically regarding the push pull method. So this kind of a push pull mechanism can happen in protocols such as advanced message queuing protocol, and also other protocols such as uh, the um, the MQTT protocol, message queuing telemetry transport protocol, uh, can also uh, can also be considered as a push-pull protocol. There are other protocols such as XMPP, and such kind of protocols, and they also have these queues and managing of queues inside the broker, and similar functions related to having a queue, and then transmitting messages from the queue to the clients. Then another protocol, another communication model is exclusive pair model. An exclusive pair model is a communication model that that initiates a communication and keeps the communication alive for a very long duration. So one of the example protocols for this is the WebSocket protocol. The WebSocket protocol has uh, the communication model related to exclusive pair. So the WebSocket is the protocol that uses a model which is like exclusive pair model. So we discussed about the WebSocket protocol, so we know the nature of its functioning. So basic difference between this and other protocols is that the communication will stay alive for a long duration until one of the client or server devices decide uh, to stop the communication. So after that, we come to this point where we have the third section of the logical design that we discussed about. So we discussed about the functional blocks of IoT. Then we discussed about the IoT communication models, then IoT APIs. So now we have to talk about the IoT communication APIs. We discussed about these first two sections as of now. Okay, so first of all, we will have Oh, I'm sorry. When did didn't you hear my messages all this time? I didn't know that. I thought you have heard. Sorry. So did you did not hear up to this point? Is it like that? Up to what point have you heard? You did not hear anything. Was it like that? Okay. Okay. So, okay. Thank you. Maybe I have muted it at some point. Okay. Okay, application programming interface. So we are discussing about the definition of the API. So APIs are used for accessing some resources from a certain web server when we want to access some specific resource. So the API is some kind of interface, and it is like an interface that gives us some resources when we ask for some resources. So let's consider a scenario as given in this figure. So when we send some request for some kind of a resources, that request will be sent to the API. The API will receive that request, and based on the request and what is the information that is included there, API will find the necessary resource from the server that the API is connected to. So the server will obtain whatever the resource and then give it to the API. The API will provide that information back to the user using a response message. So it is similar to a situation where we have a communication at the restaurant. When we are ordering some food, we typically ask the waiter to bring us a specific food. So we make the request to the waiter, right? Making the order or some kind of request is known as the request message, or the request message that we do. So the waiter will inform the kitchen and they inform the necessary people to create the food, to make the food. So after the whatever the result food is made, the food is given back to the customers by the waiter, and the customers will be served by the waiter. So basically we will be only seeing the waiter. We won't be going into the kitchen, and we won't be interacting with the chef or some other person in the kitchen. So we will be basically interacting with the waiter. So just like that, an API is something like an interface with which we are interacting with. And the API helps us to obtain the resources at the web servers. Like important or a popular API that can be used in IoT networks is called as RESTful API, and it stands for Representational State Transfer API. So there are some applications that are defined using this RESTful API. So RESTful API based applications are there. So Google Maps, Facebook, Twitter, Google, YouTube, Uber, those are some of the apps that are running with the characteristics of a RESTful API, right? So what are these characteristics? So when we talk about the characteristics, the RESTful API will use specific message type, message format to send the request message, and the response message also will have a certain standard format. So the HTTP client will send some kind of a request, and that request will consist of the messages that are related to the request functions that are available. So if we take a certain scenario where we are requesting some information from the server using HTTP protocol, the HTTP protocol can be used to make a request, and the request will be formed using the request functions such as get, put, post, delete, and the request will be sent, will be formed using a language such as JSON or XML languages. So these languages will be used to form the request message. So the languages that are used are basically JSON, XML. The commands that will be used are basically get, put, post, delete, and so on. There are other commands as well. Not only these commands, there are complex functions that are defined under the HTTP protocol. But we basically talk about these 4 commands. HTTP server will be given the we will give the request to the whatever the HTTP server, and then the server will obtain the resources from the different locations where the server is, where the resources are available. Also in this case, the different resources will be accessed, and the resources will have a certain state. So so this the state of the resource will also be considered in this protocol or in this API. So the state of the resource means like what are the updates on the resource over the time. That also will be considered once we are using the RESTful APIs. So when we go back to the definition, representational state transfer, so it means that we will be basically accessing some resource, which is a resource uh, that is uh, represented in a certain way, such that its updates are also taken into consideration. So basically the resources will be accessed by the web server, and the state of the resources will also be considered when the resource is taken by the by when the resource is obtained by the server. So the server will obtain a certain update regarding the resource, and the resource's current state will also be given to the server. So also we have to know that representation of the resource will be given to the server, not the actual resource, but a representation of the resource will be given to the server. So so basically, let's look at one example scenario where this RESTful API method is used to access the web server. And this method consists of creating a request method in a certain standard format. So the request method will consist of the API URL or the API URL, which means that the URL of the API up to which we need to access the up to which we need to access in our request. So our request needs to go to this URL point where the API is available. So up to the interface point, we will define the URL. After that, we define whatever the method that we want to get the resource. So get the resource. So if we want to do any other updates on the resource, the API method that we will use will differ. Could be get, put, post, delete. So that kind of methods can be used as API methods. And then other parameters that that we want under the resource will be defined under parameters. So a complete request message will look like this. So it will basically try to define the URL and define the method that is applied on the resource, and then whatever the specific resource that we need, that will be defined by the ID. So if we want to access a photo, then this kind of a command can be used. So this command has the URL of that photo, and if you want to get that photo, we define that the get method as the API method. Then the photo ID we will define, and that will define the parameter of the photo. So if the web server has that certain photo with that certain ID, the server will be able to provide that. So once the API gets that, the API gets the request, then it will be able to access the resources and provide the response back to the server, back to the client device. And the response will actually form in the form of uh, in the form of it can be formed using different languages in a different format. So the format of the response message can be given in terms of XML, JSON formats, PHP formats. So there are different formats that can be used to represent the response message. That can be used to create or form the response message. So the standard format is JSON format, XML format. Those are the standard formats of a response message. So they are written using these languages. So we need to consider those aspects as well when we discuss about the APIs. So uh, so that is regarding the API and how we send the request and response message and the standard format of the request and response messages. So we discussed about the RESTful API. So this is the first API we discussed about under the APIs that are used for IoT. The second API that we have is the WebSocket based API. So this is the API that uses the WebSocket protocol. So if we use the WebSocket protocol to access an API, we can call that a WebSocket based API. So that API allows us to access the server using a WebSocket protocol. So the basic protocol's behavior can be considered as the method of accessing the server. So in the WebSocket protocol, we first initiate the communication using some handshake messages, and then we will secondly do a continuous communication with the server. And then we will terminate the communication if one of the devices wants to terminate the communication. So the requests are made towards the server during the bidirectional message communication, and the necessary resources are obtained from the server using this WebSocket protocol. So in here, like a long conversation is made with the server for a long duration. So this is a comparison between REST API and WebSocket API. So I will share this slide with you later for you to see. So these are some of the like resource videos that I would like to you to go and refer. Basically, MQTT protocol based resource videos are there in the YouTube, and you can learn about MQTT using that HTTPS API. So those things can be referred through these YouTube videos as well. So these are good resources for you to learn those protocols. So that is regarding the logical design of IoT. So in the meantime, I will ask you to record your attendance. So mark your attendance if possible in this tool. So hope you marked your attendance. So I think 4 people are there. So I think it's correct. So do you have any questions up to this point? So I will share the slides with you in the LMS as soon as I can, so that you can refer from them as well. So whatever I'm teaching or showing you today, I will share those things with the in the LMS. So I will get into another presentation, and then I will give a quiz at 3:30. So okay, so I will start the section on enabling technologies of IoT. Um, I will just briefly go through this section because I don't want to like spend a lot of time on this section. I think that for the exam, I will be basically focusing on certain, areas, and then I will be, focusing on doing the lectures on those sections mostly. Therefore, I mean, I will give a lot of time to explain those things, and then you will be able to, I think, answer the questions in a better manner in that way. The other thing is that, I mean, what I'm talking today will be a beginning to those sections. Whatever that I'm going to highlight in the next sessions will be like talked about today as well. So, so IoT enabling technologies uh, is an introduction to all those sections that I'm going to continue. So, enabling technologies are basically like the popular technologies that are used on top of the IoT network. So used in the IoT networks to enable its performance, to enhance its performance. So for IoT networks to function, we need basically embedded systems, communication protocols. So without these, we cannot, create uh, IoT network. Basically, we need a way of communicating. We need a way of processing the data at the device level, and then also we have to have some maybe wireless sensor networks. This is optional in case where we use wired network. Most of the time, we consider IoT to be a network which is sometimes wireless, because although we want we although we would prefer to have wired network, sometimes we have to place our measurement sensing devices or sensors somewhere remote. So we need to keep those at the remote location. So in that case, we have to have wireless communication technology to enable the communication. Then cloud computing is another emerging trend, and computing, I mean, technologies. There are different technologies that are available. So it is also a trending technology that is enabled with the IoT networks. So as of now, even we currently have the cloud computing technologies integrated with the IoT. So some advanced methods or like subcategories of computing are like edge computing. For computing, those things are kind of being implemented as of now, and therefore that is like in the process of being implemented. So in that case, of course, we will be discussing about those types of computing. Then big data analytics. So big data means refers to large scale data, which we need to manage somehow. So, I mean, IoT systems also need the knowledge of big data and managing of such kind of big data. So the reason being that IoT networks create a lot of data, and therefore IoT networks, there are, I mean, there's big data involved with associated with IoT networks. So always we have to know how to deal with big data, and we need to process the big data such that we can get some useful data or useful information from the processed data. When we talk about embedded systems, I think that you know already what embedded systems are. It consists of microcontroller boards, and the microcontroller boards contain the processing components, memory components, uh, input output pins, and input output interfaces. Then all these components are used at the embedded system, and those components are necessary for us to do the necessary computation at the embedded system. So embedded systems are useful for us to get some input about the environment by collecting the necessary data. So after embedded systems, we talked about communication protocols that are useful. The communication protocols, they can be of different types. So based on our requirement, we will be choosing whatever the necessary communication protocol that is suitable for our network. We need to select the one that is most suitable based on the application. So that is also a crucial component in the IoT. Then we talk about wireless sensor networks. As I said before, if the sensors are placed in remote locations, we need to have a proper, like organized method of collecting the data and transmitting the data to the end destination. So if we have some collection of data, collection of data collecting points that correspond to sensor locations. So such kind of networks that are composed of sensor nodes are known as wireless sensor networks. So what I mean by sensor nodes is that the sensor node contains both the embedded system and the sensors. So sensor plus embedded system correspond to the node. So after that node collects some data, the node is capable of sending the data to the like a gateway, right? There is a gateway, and through the gateway connecting the data or transmitting the data to the internet. So through the internet, the user will be able to access the data. So in the in the transmission part, we have to uh, consider about the energy efficiency of the transmission and those kind of limitations of the environment. So if this is a wireless sensor network, sometimes we have to use some different protocols to enable the communication and make sure that the communication that we make is received at the destination. So wireless sensor networks are used in different applications. A group of sensors that are placed in remote locations um, are actually creating this wireless sensor network. So if we take a developed country, for example, sensors are placed in most places, and the collection of such sensors will be creating a wireless sensor network. So the data that the sensors collect will be transmitted to a certain location, to a certain access point, and the access point will be, doing the necessary processes on that data. So there could be some local access point, local server that does the computations. So that kind of computation will be known as edge computing. If there's some kind of a server at the local network, we call that server an edge server. If the data is communicated to the central server that controls all the different data in a central location, we call that as centralized processing, right? It could be a central, like a cloud server that does the computing. So in that case, the computing will be done at the cloud server, and it will be known as cloud computing. So these wireless sensor networks collect the data and send the data to a certain server. So basically, the wireless sensor networks are very simple networks that are not that large scale. The sensor nodes are simple, and they are not generating energy on their own most of the time. They collect and receive energy from the environment, and they use that energy to be sustainable and then produce energy for its processors. So the wireless sensor networks sometimes don't have enough energy uh, continuously to operate. For a wireless sensor network, we have to give energy from external places. The reason being that wireless sensor networks are not having enough resources to generate its own power. and therefore we need to give the power to the sensor nodes. So different methods of giving power have been invented and proposed in the literature. So there are different methods of producing energy for those sensors. So we can take energy sources such as sunlight, hydropower, any other wind power. Those kind of energy sources also can be taken as potential power sources to these kind of wireless sensor networks. So the next section that I wanted to discuss was on cloud computing. The cloud computing is an emerging technology that is widely used for IoT networks. The reason being the IoT networks collecting large amounts of data, and that data needs to be stored in a large storage. You need a lot of space to store the data, right? So if you don't have the space, you cannot actually manage the data. You might lose some data. So the cloud computing enables us the space. It gives us the space, and sometimes it gives us other services as well with related to the data. So what we need to do is we need to collect the data, necessary data, and upload it to the internet and to the cloud server that takes care of the rest of the data management process. So cloud computing can be taken into three models. Under three models, cloud computing can be studied. So the cloud computing services can be in terms of software as a service and platform as a service or infrastructure as a service. So they are known by these definitions or by these abstract words. So software as a service means that the the cloud server gives us a software uh, and it gives us the software to use, and we can use the software um, in the that is stored in the cloud server. So once we take the email, Google Drive, and other sometimes online games, these type of applications are run on the cloud servers itself. So we don't need to have the resources installed in our own devices. So we have to, however, be in the internet and have to have the internet access to obtain these resources. Then platform as a service, which is like PaaS. Then this one is a service where the cloud server or the server provides a certain application or a platform for the customer to use. So the customer can do application development and web development, database management tasks on top of this platform. The platform will be provided to the customer. So the customer can actually adjust the platform based on their needs, and uh, based on that, the customer can pay to the server. The infrastructure as a service is IaaS service. An infrastructure service is provided in case where the customer want the entire application built by the cloud server providers. So the cloud server providers need to build the entire infrastructure for the third party, and in that case, like companies such as AWS or Amazon, they actually run on top of the infrastructure that has been provided to them. So they can actually adjust anything in the infrastructure, and that infrastructure will be installed in a certain cloud server. So they can make adjustments in the infrastructure in a customizable manner according to their need, and then they can produce the output from the infrastructure based on their specific requirements. So however, this infrastructure will be installed in the cloud servers, and some examples will be AWS, Google Cloud, Azure, and so on. So these applications or these companies have built their infrastructure in the cloud servers. So the entire infrastructure is stored in the cloud. So the big data analytics is another technology that will be useful for us to do the IoT work. So when we have a certain user that is connected to our IoT network, and the user will sometimes be accessing the network through a certain mobile application or web application, and the user must be able to see the data and obtain some useful conclusions from the data. So big data analytics will provide us the ability to obtain some useful information regarding the data, and show them visually on a screen to the users. So the big data analytics will focus on data collection part, data cleaning part, data visualization part, and data analysis part. What I mean by data collection, actually data collection of course comes from the IoT network. So whatever the data that is received will be taken as data collection process. And after that, data cleaning process has to be done, which means that the data, the or unimportant data in the data sets has to be removed, and only the data that is having some useful information has to be retained. Or I mean, we have to remove null values, or not suitable data from the data set, and then we have to keep a final data set which is proper for our analysis part. After that, we have to do data visualization as well as a proper section, which means that we will be taking the data and we will be plotting them in certain plots, and we will be generating some figures related to the data that is created. After seeing those figures, we will be able to see some pattern. For example, we will be able to see there's some pattern related to some variables in the system. So based on some input data, how the output changes, we will be able to see those changes under the data visualization section, right? So plotting of graphs, right, where we consider certain input data, and based on the input data, we check the output performance. So that visualization can be used to get an idea about the performance. After that, data analysis can be used to obtain some idea regarding the future about the system, right? So some idea regarding the future, or like understanding regarding what's going to happen next, right? The patterns, what's going to happen next will be decided using data analysis section, right? So data analysis section will allow us to make some predictions regarding the data. So that is regarding the data analytics, and how it is important for our IoT network and to the user. So I think I discussed about those sections briefly about the IoT enabling technologies. So I think that would be regarding the technologies that we'll be discussing in the next sections of the class. So I wanted that to be an introduction section to the next lessons that we are going to discuss. So when we talk about the technologies, we will be basically talking in deep about, now we have already discussed about embedded systems, communication protocols, wireless sensor or wireless communications. Also, I think we have discussed up to some extent. So next, we will be discussing about the cloud computing, and then about how we can discuss about big data, and then about the basically about how we can uh, ensure the data management, and also how we can use machine learning and those kind of technologies to manage the data. Apart from that, we will also be discussing something related to networking and then managing the data in the network. So that will also come under cloud computing section, where we try to manage the network using the technologies that we have. So we will be discussing about the network, cloud computing, big data, those things. Apart from that, we also have another section related to industrial IoT that also I will do in the upcoming sessions. Right. So do you have any questions related to that point? So shall I share the quiz with you? Okay, so I will. Uh, so only 5 questions are there. So join in if possible. Is there anyone any more? I will start. Correct. So all of you got the correct answer. So we discussed that we use the JSON and XML file formats to represent the resources to the clients in the RESTful APIs. Okay, so okay, so I think this is not something I discussed specifically in the class. So the correct answer is resource not found. So when you access some resource in the web server and that server the resource is not found, we get the error code 404. The resource is not there. So other things related to unauthorized access. So it is not related to security. The 404 is not related to security, and resource is not there actually. So therefore, the error is related to resource not found situation. So I hope you got the answer correct to that one. So yes, which HTTP method is commonly used to create a new resource in RESTful API? Okay. So there are 4 request methods in the HTTP. So get method can request for some kind of resource, and the post method is create a new resource. The put method is used to update the resource, not to create a new resource. The delete method is definitely used to delete whatever the resource that we have. So therefore, the correct answer will correspond to the post method, or creating a new resource in the API. Okay, so Windu is in the lead. An example protocol following the exclusive pair model is WebSocket. Is this true or false? Okay. So yes, it is true. WebSocket is one of the examples that use the exclusive pair model communication. So I think most of you got it correct. Okay. I think marks have changed. Final question. What does RESTful API stand for? I think yeah, so both one is the correct answer. So first one actually means that first one is wrong because it is using sign word in there. So it should be state transfer. So RESTful APIs actually RESTful REST word corresponds to representational state transfer. That entire section corresponds to REST word. API correspond to application programming interface. So in the third one, it is saying real-time stateful transfer, which is not the correct one. It should be representational state transfer and application programming interface. So the fourth one is the correct answer. I hope you agree with that. So with that, I think I will publish the marks. So thank you for attending this quiz. I think the marks have changed slightly. So I think so Kavindi is in the first place. So I will put these marks in the LMS. So thank you for that. So I think with that, I will end today's class. If you have any questions, you are free to ask. Otherwise, I believe you can leave the session. So thank you so much for attending. No problem.